I'm Sean, and I am going to cover web service security, and um, we'll talk about WS security, we'll talk about OAuth 2.0, and the four different grant types, and then we'll discuss JSON Web Tokens. I'm going to move fast. I already did this recording several times, and I ran out of time several times, so I have learned that I need to speak very quickly and just spend a couple of minutes on each slide. So, why do you need web service security? Well, basically, you don't want to end up on a page like this. You want to make sure that anyone who's consuming your API or your service has confidence that their data is not going to be accessed by an unauthorized party. These are a couple of sites that you can visit to read the stories about how these APIs were hacked. Tinder just recently, someone just trolled their API and pulled down a bunch of images of their users. Snapchat several years ago was hacked, and um, you're using this application that says that your content is supposed to be secure and delete it right away, and you're able to find out all the users, all the phone numbers that are using your API. That's effectively what happened with Snapchat. So go and take a look at it. It'll kind of give you an idea of why it's important to have web service security. So WS security is used to protect XML. It can only be used to protect SOAP messages. You can't use it for REST. It's bloated, it's complicated to implement, complicated to test. They have an application called SOAP UI that was built particularly to protect or to test SOAP UI. It's really complicated. I've used it. But effectively, if you want to secure your message, this is what you have to use if you're using SOAP, and it allows you to have message integrity and also to make sure that an authorized party can't access your message. So these are a couple of terms that you should just be aware of. A claim is something that's included in the security header, and that ensures that it just provides authorization information. A digital signature is used to sign the message, and the recipient is able to recreate the signature to validate that its signature that it created matches your signature that you did. So that's where the message integrity comes in. And then confidentiality is to make sure that someone else can't read the message, or an unauthorized party can't read the message. That's encryption. So what are some of the security types? You have a username token, you have a binary token like public private key certificates, and then you have, in addition to that, you can also encrypt the message. This is an example, and as you can see, it's hard to read and very it's kind of bloated, right? It's very difficult to see. Effectively, the security header is here. That's kind of the main thing that I wanted to show you. It's included within the header. So the username token is used to pass in the username and the password. And typically, here on the left side, you can kind of see an example. It's not a complete example because it's too large to include, but on the but it gives you an idea of how to submit this with a username token. So here there's the security header, and then right here there's the username token, and then there's also a nonce. The nonce is also used to create the password digest. The recommendation is that if you're going to use this header, you should make sure to use a password digest, which is not the actual password, but a digest of it, and that will prevent someone being able to read the message. Again, this does not encrypt the payload. It just says this content is sent from a specific user or a specific system, and the recipient is able to validate that. So the binary token effectively does the same thing, except it does it with public key, private key certificates. And this is more secure because you're not passing around a username and a password nonce, or password digest, or password in plaintext. Same exact concept, except public private key certificate. So you sign the message with the private key, and then anyone that has the public key is able to validate your message. Now, if that's not enough, you are able to encrypt the message. All of this should be used with TLS, and TLS gives you that additional encryption across the public internet. But if that isn't enough, you can also encrypt the payload to make sure that the recipient is the only person that is able to decrypt that content and read it. OAuth 2.0. This is the space in which I operate. Majority of the APIs that we build, actually all of the APIs that we build, use OAuth 2.0. There are a couple of clients that still use WS Security, but typically they're migrating away from that to OAuth 2.0. And so OAuth 2.0 is a delegation protocol. Right? You're delegating one system access to another system. Right? Don't try to use it as an authentication protocol because it is not. This image I pulled directly from the IETF website. There are a couple of actors that you should be aware of. You have the end user, then you have the client application, so the end user is consuming the client application or using it, and then the user's agent is the web browser. So in a mobile app, the user agent within the mobile app, and then you have the authorization server, which is validates the client ID and the secret, or the username and password. They could be the same server, it could be two different servers, right? So one server could be validating the username and password, and then the other server could be validating the client ID and secret. And then you have the resource server, so the end user is granting access to the client application to consume resources on the resource server. So it's delegated access. What are the four grant types? Well, there's client credentials, password, implicit, and authorization code flow. And the OAuth 2.0 can be used to protect SOAP as well as RESTful messages. It is an industry standard, and it's also significantly easier to implement. And you'll see how easy it is to send a request versus what we saw earlier with the SOAP message content. The client ID and the secret are opaque, so even though someone does have access to the client ID and secret, they know nothing about the end user or the application that was granted the client ID and secret. So it's totally opaque, and it's very easy to regenerate those. And it's also more secure than passing around the username and password like you saw on the username token. So let's talk about client credentials grant type. This is used in for confidential clients, meaning that the server or the client application that has the client ID and secret is secure, so it's not publicly accessible. You're not putting this in your JavaScript pages, your JavaScript web pages, or putting it into your mobile application. It's a secure server, and you pass the client ID and the secret in the request, as shown here. Typically, it's in the payload, and it's performed over TLS. And you pass in your client ID and secret, and then you get back an access token. That access token has a time limit, and every time you pass in that access token, the authorization server validates to make sure that it is a valid token. You could also have scopes included on that to further restrict the API or access. The password grant type is again, it's a confidential client because you're able to request the end user to enter their username and password. That should be sent over TLS and secured. If you have control over that login process, then you can also perform a password grant type where you pass in the username and password in the payload, and then you pass in the client ID and secret base54 encoded within the authorization header, and then that will grant you then the authorization server validates the username and password, and then it validates the client ID and secret, then it returns an access token. The implicit grant type operates with the redirect URI, and this grant type is for public clients like JavaScript web applications. And effectively what happens is you send in a request to say authorize me, or the application would send in a request to say authorize me, and here this is the typical request. and the response type is token, and the client ID is passed in, and the redirect URI is passed in. Now in this case, what happens is the end user is redirected to a login page, and once they log in and provide consent to the application, then the application responds back to this request with an access token, which then grants the user's client app access to the resources that the resource server. The authorization code grant operates in a very similar manner. The authorization code grant operates in a similar manner. Except in this case, there are two requests. First request is, first the user is redirected to a login page. They log in, they provide consent, and then the application makes a request, or the login page makes a request to the authorization code here, an authorization code request. And what that says is they provide their client ID, their redirect URI, and then the authorization code is returned back to the client application, and then that authorization code is then used to request an access token. So there's another redirect in this case, as opposed to this grant only has one redirect and one request. This has two requests. So what are some of the limitations, right? It's built for delegation. OAuth 2.0 is built for delegation, and there isn't really a concept of identity included in the token. So you really need something else like JWTs if you want to really understand or have knowledge of the end user identity. So let's talk about that OpenID Connect, JWT. This is the latest and greatest of JWTs, OpenID Connect spec. There's again a reference at the end that will show you all the links to all the different images and the things that I have included in each page. It's basically an identity layer built on top of OAuth 2.0. And when you submit a request, you're actually passing OpenID as one of the codes in the parameter, query parameter that you pass in. So JWT stands for JSON Web Token, and it is similar to SAML and the WS Security Username Token. The difference is that it includes the difference is that it's JSON and it's much more compact, but it also includes claims, so authorization claims about the end user. Why is it different? It's definitely less verbose. It can be compiled or it can be encoded into, typically it's base64 encoded, and here you can see this is an actual JWT, and you can copy and paste this JWT in this site, and you can read the contents of it. So that is a JWT. It's unencrypted. It is not signed. The advantage is that it can be easily encoded, and you can pass it around in the authorization header. Now what this means is that if you're passing around a JWT, all the services that are consuming that are now able to read that JWT and pull out authorization content and make decisions about whether or not the end user has access to this particular service. So it can be decoded and parsed easily. It's very friendly because it's very web application friendly because it's based in JSON, and all the claims are present. The disadvantage is that it's not encrypted, so anyone can read the content, but there is a way to encrypt the content. So JWT is unencrypted. There's no message integrity. JWS is signed, and it can be decoded and read by anyone. So that's a problem. If you don't want anyone to read it, then you use JWE, which is an encrypted token and encrypted content. Alright, these are the references. Please feel free to take a look at them. I used a lot of stuff from the company for which I work, Apogee website. Has really great content. OAuth-lib is another great site that talks about the OAuth 2 protocol, and then IETF. Well, you can't see this one, but OpenID Connect down at the bottom has all the protocol information for OpenID Connect and JWTs. Great site to visit. Thanks for listening.